Hey everyone, welcome back to my channel. Today we're gonna solve the set matrix zeros. We're given an n by n integer matrix. We're gonna go through every element in the matrix, and if there is an element is 0, we need to set its entire row and column to zeros. Say we have a grid and there is a 0 in the center of this grid. According to the problem statement, if there is an element is 0, we need to set its entire row into 0 and its entire column into 0. The result is over here. Another thing I want to mention is that we need to do this in place, which means that the element that needs to be changed should take place in its original position of the grid. There are also two follow-up questions on the space complexity. The first one is that can we achieve O(n plus n) space complexity? And the second one is can we further improve our algorithm to achieve the O1 space complexity? How are we going to do this? The most intuitive way to solve this is we go through every element in the matrix, and if there is a 0, we will just update the whole row and the column to set them 0. But in this way, there is a problem that we're just overwriting the element that we haven't visited yet. So when we go to the next value, it should be 1, but now it's 0. So based on our algorithm, we will set the whole column to be 0. And that's not the result we want to see. We may say that we can have a copy of the matrix to solve this problem, right? So the copy one will update the 0 element for the rows and the columns, and the initial one will just help us to see the original value in the matrix. But remember, we need to do this to solve this problem in place, which means we should not create a copy of original matrix. So copy is not allowed. How are we going to do this then? One way is to create two arrays which indicate the rows and the columns. In the same way, we go through every element in the matrix, and if there is a 0, we will not update in the matrix, but we will mark the cell of the array in this column and row. Then we'll go to the next element. After we go through every element in the matrix, we will go back to see these two arrays. You may use a for loop to check every array, and if there is a mark, we will update the value in the matrix and to set the whole column and the row to be 0. And we will get the result. In this way, we will achieve n plus n space complexity, and we will change it in place. So for the time complexity, because whatever solution we use, we will always go through every elements in the matrix. So the time complexity will always be m times n. Okay, is there any chance we can solve this problem in just constant space complexity, which means O1? The answer is yes. Well, we basically just remove most of the arrays we previously used and just keep one extra space. What we are going to do is use the first row and the first column to replace the extra spaces. Because there is overlap on the top left of the matrix, so we will just keep one extra space to indicate the row information. So we will still go through every element in the matrix, and if there is 0, we will mark this column and also mark the row. After we go through every element, we will check back the first row and the first column to reset the entire rows and columns that are marked. So how does this solution work? Well, every time we mark the cell in the matrix, we are overwriting this element. However, different from what we have done in the previous video, we are not overwrite the element that has not been visited. In this way, the element that has been overwritten will not affect other elements in the future. So we will set the column to be 0 and the rows to be 0. Let's see how we're gonna do this in code. So we wanna achieve the constant space complexity, and we wanna get the rows and the columns. Okay, so since we need to have one cell of the extra space, we will use a Boolean variable to indicate that. So the default value is false. The first thing we're gonna do is to go through every element in matrix. We will use the nested for loop. If the element is 0, so first we will set the first row and the corresponding column to be 0. And for the row, basically we want to do the corresponding row and the first column to be 0. But remember that there is overlap on the top left cell, so we have extra space to store the information of the first row. If it's not the first row, we will do this. Otherwise, we will update the Boolean variable to set it to be true. After we go through every element in the matrix, a little bit different from what I said in the previous drawing, we will not directly go through the first column and the first row. We will first reset the value for all the elements that are not in first row or first column. So in this way, we will start from the second row. So we start from 1 and the second column. If the first row or column for the current element is 0, we will set all the elements in this row or column to be 0. Okay, so after we reset the value for the elements in the matrix, regardless of the first column and the first row, we will deal with the first column and the first row. So the top left element indicates the column information. So if it's 0, we will set the first column to be 0. The Boolean variable row 0 is to indicate the first row. So if row 0 is true, means that the first row should be reset to 0. Because we change this matrix in place, we don't need to return anything. That's the end of our code. Let's see the result. Our memory beats 30% users, and the runtime beats 72 users.